Okay. So there we go. And now we can see a light beam over here. So first thing that I'm going to do is I'm going to show you how light reflects using a mirror. So here I've got a little mirror, and here I have a little protractor that we can use. So here we go. Let me just align the mirror nicely with that line. So now, if we look over here, I'm gonna have to turn off the screen. There we go. So there are less light everywhere. There we go. Now we can actually see things. Okay. So here is our incident light ray coming in, and this fainter light ray over here is our reflective light ray. And you guys can't see it very well at the moment, but they are exactly equidistant from the center line. So let me see if I can turn this screen back on so we can actually see that. Okay, never mind, you just take too long. Okay, so now you can see there's the incident ray, there's the reflected ray, and you can see that they're the same distance away from that line there. Okay, so that is how reflection works. And as we turn this, you can see that they stay the same distance away from that center line. So no matter which direction your light is coming in, it will reflect nice and neatly. Those angles will stay the same. Okay, so put away my mirror and my big protractor. Now I can show you guys a rainbow. So this is very faint. So here we go. This is a prism. And as we put the prism in, oh, I hope you can see this. Let me just move it a bit so that we can see it there a bit better. So over here, it's forming a rainbow. So let me grab a piece of paper. Here we go. So here, you should be able to see a rainbow forming right over there. So this is how we can split light into its color components. So unfortunately, I can't really zoom, but I can pick it up and move it. So let's try that. So there we can see the rainbow forming. So that is light split using a prism. Okay. Okay. So now I have some other goodies. So wow, that is very bright. Okay, so I just want to move my light box here. Take out this front bit. So here, it's got little slots where I can insert all sorts of different things. So here, I have some colored filters. Let me just light it up so you can show you. So this is a red one. And I have a bunch of different colors. So we are going to look at what happens with light in different colors. So I'm going to put our prism away. We're going to use this little thingy over here. So it shows all of the different colors. There we go. So it's got black, it's got white, and then it has the different colors in between. So we can see exactly which color shows in which colored light. I'm going to take out this little front bit. Put my light box back. So here we have white light, and we can see all of the colors in white light. So let's pick a color over here. I have some blue. So we put in a blue filter. Now, if I can get this in, there we go. There we go. So now we have blue light coming out over here. So if I put this over here, now we can see exactly what kind of colors we can see using blue light. So we can see the white, that's this side over here. The black still looks fairly black. So now we have the red starting over here. So this is red, and we almost can't see it. It's pretty much black. There's green, it's completely black. There's yellow, we can see a little bit of the orange. And here's our blues. They show up fairly well. Let me just turn it so that they are slightly more in the light. So our blues still look very blue. Okay. So now we can do this again using a different colored filter. So I have a yellow color filter here, which I'm now going to put in. Okay. So here we go. So this is yellow light. So in yellow light, we can pretty much see all of the colors showing. Is it? No, it's not quite down. There we go. Now it's down. So we can pretty much see all of the colors showing. Some of the colors look a little strange. This purple looks almost black. The blue looks slightly strange, but otherwise our colors, we can still sort of distinguish them. So yellow, let's see, where is a green? Here is a that is a cyan. Red. Green. So green color filter in. Go. And we have some light. There we go. Okay. So now we have green light. So in green light, we can see white. It looks slightly greenish at the moment. I have a feeling that's going to be happening quite often. Okay. So in green light, our blues over here, they just look black. And on the other side, our red also just looks black. We can see yellow, we can see green. It doesn't show up very well in this camera, but we can see it. And then we've got our yellows and our oranges, and the very, very light blue, which is almost white, we can see very well. Okay. So we had yellow, we had green, and we had blue. So let's try a red filter. Here we go. A nice red filter. Okay. So now we have red light over here. So what colors can we see in red light? We can see our red, our orange, and our yellow fairly well. They look slightly orangey. Our red looks red. Our white looks slightly reddish. And then if we look at our blues and greens, we can't see our blues. They just look black. And our green also just looks black. This light blue has quite a bit of white in it, so we can see a bit of that. So, which colors have I not done? I haven't done cyan. Let's do cyan. Okay. I have a cyan filter in. So here we go. So cyan is a slightly bluish light, and it behaves fairly like blues do. You can see our blues. This color here, the light blue, which is actually cyan, shows up very brightly. And our reds are pretty much black. Okay. So this is our color filters that we've been using. So now, if we want to try and see what happens if we use two different colored filters, we can actually insert two different color filters in here. So let me just get a bit of light. Sort of halfway. So I have a green filter here and a red filter. So here we go, a green filter and a red filter. And red. So now we can see what happens if we combine these two. So here we have green and red. So I'm just going to set up our light box. So our green filter is going in. And then I'm just going to halfway insert this. Like that. So here our green filter is in, and we can see it's very green. So now, as I'm going to insert the red filter, you'll see what happens with the light. So green and red cancel each other out. There is absolutely no light coming through the front over here. So let me just show you guys again. Here I'm taking the red filter out. Okay, now I'm going to take out the green filter. So you can see red, and as I put in the green filter, all of the light goes away. So there are some very cool effects that we can do with this. Here I have a green and I think this is blue. It's blue. Great, so let's try this. I'm gonna put in a blue filter. So there we have blue light. And here I have a green filter. So now we can see what happens with the light. So why does blue and green also make all of the colors go away? If I have a blue and here I have a yellow filter, if I insert that, what's going to happen? If you look closely, the light is actually greenish here. It's hard to see on my hand. Let's grab that paper again. So the light here is green. Okay. Let me take out the yellow again so you can see the difference. So that's blue. There it's greenish. And if I take out the blue, you'll see it's just yellow. Okay. So this is magenta. So there we go. And if I have this is green. Where's my blue? Okay, that's cyan. There's my blue. So red and blue doesn't actually block out all the light. It just makes it very purplish. Green doesn't kill all of the colors. Have you guys heard about RGB colors that you get for PCs? So what that means is that all of the pixels on your screen is essentially made of red, green, and blue little pixels. And then due to the fact that they work together, they can show the different colors. So if the green pixel is very bright, then you will see lots of green. If the green pixel is very dim and the blue pixel is very bright, then you will see blue. If you've got the blue and the red pixel both equally bright and the green very dim, then you end up with a purple color. So we have green here, and we have red somewhere. There we go, red. The green and red are complementary colors, and that's why it cancels out all of the light. So here I have an orange filter. So let me show you guys over here, then you can see the color. So here we have an orange filter going in. So we can still see our color over here. It's actually slightly yellowish. Still greenish, but slightly yellowish. So there are lots of fun we can have. Here's a cyan filter. This should make our green go a little bluer. Okay. So our green is overall just a very darkish color. Cyan, magenta, and yellow. So that is cyan, and now I'm going to insert yellow, and that will make green. So cyan and yellow makes green. So let me talk to you guys about the primary colors just a little. I'm going to turn on the light 1 second. So we get two different sets of primary colors. You get red, green, and blue, and then you get cyan, yellow, and magenta, which is a slightly pink color. And have a true magenta here. So there's blue, there's green, and that one is sort of red. Does one work better? Nope, they're about the same. And then we have some orange and some blue left over. So these are our two sets of primary colors. And I know they look very, very dark here. So these are the colors that a printer will use to make your different colors. So when these mix, you will get green, or you would get orange. It's slightly hard to see. Or you would get purple from that. And if you mix all three, you get black in the middle. These are what light uses. So essentially what our PCs use on the screens in order to display different pixels. If you guys want to have a light box that you guys can play with, it is remarkably easy to get one. Literally, you have a small cardboard box that you can stick your phone into on one end. Then you've got a little light box. So then the only other thing is you can get little, these are pieces of plastic and they've got some slits in them. Got one with 1, one with 2, and one with 3. And this is to show all sorts of different things about light. So this one, if we use the 3 one, then it'll show that light travels in parallel lines. So this is essentially where your books end. It shows you different colors in different kinds of light. So now I'm going to be delving into what you guys really don't need to know, but which is actually kind of cool to see. So let me just go turn off the light again. Okay. Grab my flashlight. There we go. Okay. So I'm going to put in this little 3-slot one. And close this up. So we have 3 lines of light. Okay. So this, you guys are not going to be doing in foundation phase at all, but it is really cool to see. So these are lenses. So I want you guys to see that this lens bends light away. So here we've got the light coming in, but this lens will bend it away. Okay. And then we have another lens. That one is called a concave lens. This one is called a convex lens. This one will bend light towards themselves. So you can see they're going closer together. So this is the way that glasses work that people wear on their eyes, is using essentially convex and concave lenses. If you can't see close to yourself, then they use a convex lens. And if you can't see far away, then they'll use a concave lens. So here's my glasses. So we can see what they do. So you can see it bends the light away just a little. So that shows you that I can't see close. I can see close to me, but I can't see far away. So yeah, there you guys learned a little bit of optics. And lastly, what I want to show you guys is light bending. So I'm going to put in the one slit one again. There we go. And here I just have a block of glass. So if I put this block of glass down here, you can see that the light is just going straight through it. I'm going to move the camera a little closer. Don't be scared. There we go. Now I'm just going to turn this block. So there we go. I can turn it a bit more, but here you can see it's starting to reflect off just a smidge. But here you can see that the light is literally bending inwards into the block of glass, and then it bends outwards again. So this line and this line is parallel, but in here it bends quite a bit. So this you guys will have seen at places like swimming pools and ponds, where the water is nice and still. And then the objects inside the water will actually look slightly closer than they would actually be. Or if you put a straw in a glass of water, it looks like the straw bends. So that's this effect. It's literally because the speed of light slows down inside objects. So inside water, inside glass, things like that, the speed of light slows down just a little from here. And so we get these dramatic bending effects, which is really, really cool. So last thing I want to show you guys is how fiber optics works. So here I have a prism, right? And on this side, it's got a very extreme point. So now I'm going to put it into the light here, like that. And then I'm just going to move the camera closer so you guys can see. I'm just going to move everything closer to the camera. There we go. So you'll see the light comes in over here, and then it does this weird zigzag thing. And this is how fiber optics work. It's called total internal reflection. So the last few things that I showed you guys, wow, I look scary in the dark. Let me just go turn on the light. So the last few things I showed you guys, the lenses and this fiber optic thing, you guys don't need to know in Foundation 1. But it's one of the coolest things that you can do with light.